So you're gonna get logged into your Chromebook. Should have received an email from me. It's probably a Google form. It's probably called a bell ringer or cut in half activity kind of a thing. You're gonna work alone on it. You can submit all of your answers in that actual Google form itself. Don't use a calculator. I know the Chromebooks have one. Don't try to use it. I want to just see kind of what you can do off the top of your head. Submit your responses in the actual Google form. Make sure that if it asks you to log in, like when you're clicking on that form, make sure you log in with that GGB school account. I'll give you about 5 minutes or so. Just try it out. I'll just kind of see where we're sitting right now from yesterday. So Alexis.
Oh, I was with band.
Yeah. Is Alexis with you too? Is she in band too?
Which one?
Hanging out?
No, she's not.
Where she's at.
She was in my first period, so.
Okay. All right. If you just walked in, you were saying, get logged into your Google account on your Chromebook. Pull up your email. I should have sent a Google form a little bit ago about a little 5-minute bell ringer activity called cut in half. Work alone. Don't use a calculator. Try to avoid a calculator at all costs.
Is this graded?
No, I just kind of want to see where you're at. I just want to kind of see what you have. Submit your answers.
Was the first question all graded one?
What was that?
Is the thing with the 12 or graded one?
Yeah, so you're just submitting so it's going to give you a number, right? The number has a star next to it. It just wants what half that number is. If that makes sense. So it's good. So. And just go through, scroll, keep hitting submit. I think there's maybe 10 or 11 questions. It might be 13. I don't know how many responses I had. I don't know if a name was one of the responses. So cut it in half really quick, go to the next one, cut it in half, go to the next one, that type of thing. I just want to see how quick you can do that. Give you another 4 minutes. Once you've hit submit, you're good. Close it. You're good. This is just a quick little activity. I kind of want to see where you're at from yesterday because that's really what we spent most of our time doing yesterday. Always make sure you hit submit. Yeah, there was 11 questions. Just a reminder as you're working, cutting those in half, try not to use a calculator. Just want to kind of see what you can do mentally. This is the last day to do an add drop to change your class schedules today. I think by 2:30 or something like that today. So keep that in mind. So if you're trying to get your schedule worked out, today's the last day to do it.
Would you be able to send it?
Okay.
11 early to 1.
Oh my God.
You want us to close computers, right?
What?
You want us to close computers?
Yeah, just close them when you're done. Yep. That way I kind of know where you're kind of sitting. Yeah, not great. I just kind of see where we're at. How quick do we catch on yesterday? How quick are you at mental math right now? We're gonna keep doing those kind of every once in a while. Every couple days, we'll do another kind of mental math kind of thing. Keep you sharp on it. We'll eventually go over the answers. That'll be probably tomorrow. Got everyone? Okay, so everyone's Chromebook should be closed. Perfect. All right, so thank you for doing that. I just kind of want to get a sense for kind of where we're sitting right now. I want to kind of look at doing a couple more of those, just because the number one thing that from Algebra 1 to geometry, people lose their mental math ability, you know, add, subtract, multiply, and divide in their head. Just simple numbers sometimes, 2s, 3s. And it's just one of those things, like if you just keep practicing it a little bit, or you learn strategies for it. That's what yesterday was all about, like introducing how to divide by, you know, certain numbers. Today, this is kind of our goal, right? I'm gonna do a factor tree again, one more time. This is what our homework's based on, right? I'm gonna break down numbers into factors, factor trees without a calculator. So trying to learn the little strategies, like how to divide by 2 really quick, or divide by 5. Prime factorization is gonna be probably our main goal today. I introduced yesterday as just kind of like one example, but I want to do that one more time because there is kind of there's that easy process of doing it where you don't really have to think about your problem. I'm going to show you that today. We call that one sock method, like juke sock or hockey stick. With prime factorization, you have to use prime numbers. So I'll give you that list today. This list better be in your homework, but notes somewhere, so that way you kind of know what numbers you always should check. And then our last couple problems I'm going to do today is common factors. So my goal is to go about 10 minutes or so, kind of go through these to make sure that you understand basically these 2 topics. And then once we're through that, you're going to get an assignment today. Okay, the assignment will be due Friday.
Can we do it with partners?
Yeah, you gotta work together. So no calculators though, try not to do that. And don't just copy your neighbor. So if you're that person that doesn't know what they're doing, don't just copy your neighbor, like ask questions. But I don't mind if you're kind of walking through things, double check answers. I don't have any problem with that. So we'll get to that. The goal is by tomorrow, I want to get to this next section. So like it's completely different section. It's using this stuff, but completely like a kind of a 180 in terms of topic. Okay, we understand what we're doing today. Okay, let's jump right in. Let's talk about it. So here's our first couple examples. I'm going to do 2 and then maybe get to a greatest common factor problem. So first number I'd like you to write down. Write down the number 7. Okay, what we're going to try to do is we're going to try to break this number down into factors. So if you don't remember what a factor is from yesterday, it's 2 numbers that multiply together to give me this thing. That's what we're doing today. But without a calculator. Now that's the hard part, right? Is getting up to every single number. Not just the first couple you can think of, but every single combination that would give us 70. That's our goal. So again, put these in your notes, take the notes, you know, so that way you got something you can look back on how did Mr. Ward do it. Now, my goal is to show you, I would say the easiest way of doing this. Some of you are probably super good at this, you can probably already rattle them off. Some might look at this going, yeah, I don't remember how to do that. You know? So, I want to get you to the point where you can do it really quick, super easy, and you don't really have to think too hard about it. Okay, so my way of doing this is to use prime numbers, like I said earlier. You know, the prime factorization. Now this method I'm going to show you helps me get the list of all the numbers that you can multiply together that will give me 70. That's the goal, is to make these lists of like pairs of numbers. I have no idea how many pairs it will take to make 70, but I have a pretty good idea of how to get there. Okay? So obviously one of the pairs we talked about yesterday was 1 and 70 itself. 1 times 70 gives you 70. You should always get that one first. You should never forget that one. 1 goes into everything, 1 in the number itself. Now the problem is, I want to try more than just that number. So what I'm going to do is, I want to get to this list of every single combination that we can get to, but I'm going to use this prime factorization to do it. This sock method. I don't know if you want to call it sock method, you want to call it hockey stick. Okay, so to do prime factorization, you have to use prime numbers, right? So the prime numbers from yesterday, if you don't remember, prime numbers are numbers you can't break up any further. They're broken down as far as possible. The numbers that we talked about yesterday was 2, 3, 5, 7, 11, 13, 17, 19, 23, and then you just keep going. Typically, you should not have to go past the number 23. If you're going past 23, you're doing way too much math. You've probably lost that there's some number in between. So these numbers cannot be broken down any further. It's like 1 and 2, those are the only 2 numbers that make 2. 1 and 7 are the only 2 numbers that make 7. There's no other ways to break it down. That's why we check these numbers. Now, what I would do is if I start a number like 70, okay, we already know that 1 and 70 went into it. That's just one of the pairs. I already know that. But when I do prime factorization, I don't even try the number 1. The reason being is that 1 goes into everything. There's no point in trying the number 1. So what I would do is start with the first prime number. Will 2 go into 70? Yeah, it should. Now the reason why. What did 70 end with? A 0. It ended in an even, right? 0, 2, 4, 6, or 8. So we know 2 should go into it. So we're gonna divide this by 2. So now when I do prime factorization, when I do the SOC method, I always put the number that's in this list that I know works, I put that number off to the left. It's just this little pet peeve of mine. Put it to the left. And now what we're doing is we're splitting it in half. That's what dividing by 2 means. What's half of 70? Anyone happen to know what's half of 70?
35.
35. Boom. Half of 60 is 30, half of 70 is 35. Okay. Is there any questions with how we use the 2? Split it in half. Now, if 2 didn't work, let's say you tried to divide by 2, but it was a weird decimal, 2 doesn't work because it probably didn't end in an even number, like 0, 2, 4, 6, or 8. So if 2 doesn't work, just skip that one. Just move on to 3. Okay, that's what you do. And then if 3 doesn't work, try 5. That's just the process that you go through. Okay, does everyone feel comfortable with the first one? Okay, now that we're there, since 2's on the left, we're going to go over to the right number, and we're going to see if we can break this down even further. Okay? So, the number I always check, I'm going to check 2 again. I start over. So does 2 go into 35?
No,
No. Why not?
because it doesn't end in even number.
Exactly. Right? It didn't end in even. Ended in a 5. 5's not even. Right? That's an odd number. So don't even try 2. We're done with the 2's. So the next number I'm going to try. I'll try 3. See if 3 works. So to check for 3, check for the number 3. I take 35, add them together, right? Take 3 and 5, add, that makes 8. Does 3 go into 8? No, it doesn't. 3 goes into 9, 3 goes into 6, doesn't go into 8. So 3's out. 5 does. Because the reason why I know 5 does, it ends in a 5.
So,
Yeah, so 5 and 7. So boom. So we had 5 and 7. Now, I know I'm done. The reason why I'm done is the last number on that left or the right side over there, that's right here. I'm done. I've only got the prime numbers.
Wait, how do you get the 7?
Taking 35 and dividing it by 5.
Oh,
Yeah, so you're always dividing as you go down the branch.
okay.
And this is how I know I'm done, is when the last number on that right side was a prime number. It was in my list up there. Now, if 5 didn't work or 7, try 11. See if 11 worked. If 11 didn't work, try 13. You go into the point where you know the numbers in that list are all the way broken down. Okay, now, if you notice what I've done here, I've circled all my numbers. My 2's, 5's, and 7's. I'm circling all the prime numbers that were in 70. That's why I always put the prime numbers on the left, and the last number should be the last. That's why it looks like a tube sock or a hacky stick. So I'm going to list these off over here. 2's, 5's, and 7's, right? Those are all the numbers that are prime that were from 70. All right, so I'm going to stop there just for a second. Do we feel comfortable with the prime idea? Now, here's the hard part. If you're not very good at dividing, this can be a pain. I understand that, right? Because you're like, well, I didn't know how to divide by 5. Or I didn't know that 7 went into it. That's the part where you got to get used to. That's why having these multiplication charts I gave you yesterday can help, because they can make smaller numbers easier to deal with. So, let's see if you gave me that one yesterday. But I think everyone got one of these yesterday, correct? Your print. This would be helpful. I think Eric did go into it. That's right, you're welcome. Here, still work on that one. Okay, so that will help you. That way you can kind of look at something, okay, I know 5 and 7, I can go from there. Okay, so now why I did this, like there's a whole reason why I went and did this thing, is because 2, 5, and 7, those are my next couple numbers. That's why I did it. That's exactly the reason why I did it. That makes my entire list right there. Like I don't have to check any other numbers. Those are going to be the numbers that are left from my list. So now, how do I know what numbers go over here? That go across from 2, that go across from 5, go across from 7. Here's the easiest way I can teach you how to do it. Okay. Do you agree that these are the numbers I just had for my list, right? From over here? To get the number that's across from 2, to get the number across from 2, all you do, so I want the numbers across from 2, take these two numbers that are left, that are not the 2 itself. What's 5 times 7? That number goes there. Whatever numbers are left, those go on the other side of that digit. So, my next number on the list was 5, right? So in this list, if I ignore 5, these are the other 2 numbers in my list. What's 2 and 7 multiplied together? That goes there. And then the last number was 7, so I'm here. Yeah, so if I have 7, you multiply the other 2 together. 2 and 5. Yeah. So 2 and 5 make 10. And multiply. 2 times 35 is 70, 5 times 14 is 70, and 7 times 10 is 70. Those are all the factors. Do you see why I do the prime factorization? I want those 3 numbers, or 4 numbers, or 5 numbers, whatever these are, whatever list is here, and I'm going to pick one of these numbers, put it on the list, and then the other numbers that are left over, multiply those all together. And that will give you the list. That's why I do it. Now the problem is you can make different combinations of them. So you gotta, like, if there's multiple 5s or multiple 2s, you have to make every combination of numbers that are left over. That's the only issue. I think this is probably the easiest way of doing it. It's not the only way, obviously, because yesterday what we were doing, I think I taught you 2 different methods yesterday other than the sock method. I just said, okay, try 1, see if it works, try 2, see if it works, try 3, see if it works, try 4, see if it works, 5, 6, 7. And you go to the point where these numbers are nearly the same number. But the problem is with doing that, that requires that you know how to divide by 5 or divide by 7. This process, you don't have to think about it. You just break them down into all the numbers you can possibly come up with. All right, questions at all about the process here? Okay, all right, let's try another one. Try another one. This will be one of my last ones we're going to move on. Okay, so I'm going to leave this on the board. Let's do something a little bigger. We did 70. 100. 100's not bad. Let's do 100. 100. That's good. Let's do that. Let's do 100. All right. Now, obviously, the goal here is to make every list of combinations that multiply to give me 100. I have no idea how many it will take. I want to make every possible combination. Now, what's the first one we know for sure?
I guess we're in half.
Yeah, okay, we'll do that here in a minute. What was the other one? 100. Okay, so we better start with that. Better not forget that. 1 and 100. Now again, we're going to probably go 2. Okay, I already heard we'll split it in half. We'll go that route. So we know 100 on 1 will work, and then we're going to go on. Now, we can do it by the prime method, where we break it down to all the different combinations. We could just try to guess and check numbers like 2 and 3 and 4 and 5. So it's kind of your style, however you want to do it. But remember, the goal is to get every combination possible that will give me, 100. That's the tough part. I want every combination, every single pair. So what I'm going to do, I'm going to do the prime factorization one more time. I'm going to do this little stock method. What number do we always check with primes? 2. So we're going to split in half, right? 2 and 50. Okay. Notice the prime numbers on the left. I always try 2 first. So 2 definitely works. And it into 0. Okay, so I'm at 50. Can I do 2 again?
Yep.
Yeah, okay, you can.
25.
2 and 25.
And then this one is then for 5.
Yeah, so at this point, I can't do 2 again, so I'm done with 2s. 25, I can't do 3s. 3 doesn't want 25, but 5 did. 5 worked, what, 5 and 5? And I know I'm done there, because the last number on the right side, that was a prime. So boom, there you go. There's every combination. So I have 2s, and I have some 5s. So I know for sure those are going to be in my combinations. 2s and 5s will definitely be in there. Those are numbers in that list. They probably should be on that list. Now there'll be more, don't get me wrong. but those are two numbers for sure I need in that list. Okay, do we understand how I'm making this list like kind of quickly?
Nope.
Okay, let's do 2. So I already picked 2, right? That was one of my numbers I just chose from my list. So 2 is here. So that was one of the 2's. So now what you do to make the number that goes on the other side of it, you take the other numbers that are left and you multiply these together. So I'm taking 2 times 5, which is what? This is 10, and multiply it by 5. What's 10 times 5? 50. So that's the number that goes across. So whatever number you have in that list, and it's all the other numbers multiplied together. So now the next one, same thing again. I picked 5. Right? That was the number in my list. 5. And I multiplied all the other numbers together. So 2 times 2,
4.
take it times 5. 20. Okay, so those are those. Now we're not done yet. Now the reason being, do you agree that I've used my 2 and 5, right? Use those. But now the other thing I have to check is, can I multiply those numbers together and make other numbers? Because I have 2's and 5's and whatnot. So, for instance, what do you get when you multiply 2 and 2 together?
4.
That's in the list. That better be in your list. It's one of the numbers. You better check 4. Again, how I made 4 is I multiplied these 2 together. Right? These are the 2 numbers I multiplied together to get 4. So the number that goes across from 4 is the other 2 numbers left over. What's 5 times 5? Boom, that goes here. You can make combinations of them. So I did 2 and 2. I already did 5 and 5, that made 25. 25 is on my list already. Yeah, so we can do 10 now, right? We can do 2 and 5 multiplied together. That's 2 and 5 multiplied together, that's gotta be my list. And so what are the other 2 numbers that are left over? 2 and 5, so it's 10 again. 10 and 10. There you go, that's the entire list that makes 100. Just using that list and doing like every combination of numbers together. And not repeating them. So boom. And that's how I know I'm done, the 2 numbers are matched up. They're not in order, they don't need to be. Alright, now here's the thing. I don't know if this is clicking for you. I don't know kind of where you're sitting. Maybe it does. Maybe it's like, oh, that's kind of easy. But it requires that you know how to multiply and divide. I mean, that's the whole point of doing this stuff. Okay, questions? Okay, now, the last part today. Greatest common factors. Greatest common factors is when you have 2 lists of numbers and you're looking at what is the biggest number they have in common. Now, the last one we just did a little bit ago, we did the number 70, correct? We just did that a little bit ago. What were those combinations for 70? Anyone have those notes?
2, 35.
Okay, 1 and 70, 2 and 35, what was the other one?
5, 14.
5 and 14, what was another one?
7, 10.
7 and 10, okay. Those are all the numbers, correct?
Yeah.
Okay. All right, so for greatest common factor, for GCFs, greatest common factor, all you do is you look at this list, you look at this list, and what's the biggest number they both share? 10. They both shared 10, that's on the list, on both of them. That's your GCF. GCF for 70 and 100 is 10.
Oh.
It's the biggest number in both lists, that's all you do. So I don't care if, you know, they don't have to be in the same spot. They just, whatever numbers in this whole list of numbers and this whole list of numbers, what's the biggest number they both share? It was 10. Okay, questions? Okay, all right, I'm gonna turn you loose on homework today. This will be due on Friday. You do need to put your name on this. You will be turning this in. I will be grading this. This will be in the grade book. Okay? Now, it's 2-sided. It's got 6 problems over here. It's got 4 problems on this side, so it's a total of 10 problems. That's your entire homework for 2 days. Now, put your name on it. No calculators. You can work together. Just don't do the whole copy thing where you just copy your neighbor. Like, actually legitimately try to break some of these down. Remember, this is the goal, is to make these lists of these numbers, like every combination that can possibly work. Okay, I will have a copy of this on my website in case you misplaced this. You can just print out another.
Mr. Warren.
What?
Mr. Warren.
I've already.
Okay, the rest of the time is yours. You can work at your own pace. You have about 7-8 minutes you can keep working. I like to give you at least some time so you can ask questions. I'm gonna leave this stuff on the board in case you need to look at it.
Ben.
Yep, don't be